I don't have any good dad jokes at the moment. I will need to get some of them ready. So let us just double check. I see yes, 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 and yes. It does look like we are live. And let me just quickly double check on the AWS side. It's always worth checking because I've had some fun issues.
I am actually going to tweet about this.
No, I actually didn't tweet. Thank you.
I'll do it. You make the intro. You make the people feel welcome here, and I'll do the boring part.
Awesome. So welcome everybody. Let me just see. There we go. Okay, now it seems to be going. Finally. Cool. Welcome everybody to this week's episode of Developers Let's Code, where we focus on helping developers that are just starting out with AWS and their cloud journey and show them ways to build things on AWS and go through a couple of different topics. And today's topic is on relational databases. So what we're going to do is we're going to start off a general discussion around all the different database types that are available, and just give you an idea of there's relational, there's key value, there's document stores, etc. There's a whole bunch of different categories of databases. And then what we're going to do is we will dig into relational database a bit. So specifically, we'll be taking a look at Amazon RDS, which is Relational Database Services. And then we'll spin up a cluster or two. And if we have enough time, we'll even play around a little bit with a data warehouse by using Amazon Redshift for that. But before we get into all the other fun, let us quickly introduce ourselves. I always get Darko to come join me on these sessions because I feel it's a lot more fun chatting to someone than just staring at the screen and broadcasting at people. So Darko, introduce yourself to our viewers.
Hello everybody, my name is Darko Mesdaros. I'm as the same person right next to me. I'm a developer advocate at AWS, based in Berlin, Germany, originally from the lovely Republic of Serbia. I cover Central and Eastern Europe plus the Russian regions. I am basically the same thing that Kopus does. We all both do DevOps and automation. We're both bald and have a beard. We actually, a lifestyle choice and a beard. And been working for AWS for the last 5 years. I'll be supporting Kopus today.
Okay, awesome. My name is Chris Bernard, and I'm also a developer advocate. I am based out of Cape Town in South Africa, however, so I'm all the way down in the Southern Hemisphere. And as Darko mentioned, pretty similar backgrounds around automating DevOps, helping people move to the cloud, building in the cloud, etc. So what we are doing today in this session is we are taking a deeper look at relational databases. So what we're going to do quickly as a start is I am going to, let me just quickly get my notes up over here so I make sure that I cover everything. We're going to start off by looking at the database types available. So let me just share the screen, share this one, and apologies for not putting it into presentation mode. I'm a little bit concerned because I had some weird issues just now where my one screen decided that it no longer wants to receive anything when I switched it on midway through. Yeah. So yeah. And hey, Denny. Welcome to the show.
That's a reaction.
That's more like a hey!
That's a reaction I have every time Kopus makes a dad joke. Like, hey!
There was a great dad joke recently. I'll see if I can remember it, but I was like, I need to remember this one. I need to write it down.
Well, damn. Yeah.
Mm-hmm. Cool.
Okay.
Now tease done. We are ready. Awesome. No, sorry, we are not for hire at the moment. At least I am not. I don't know. Ask the Darko about that. But
no.
Before we dig into the actual relational databases, let's take a look at some different database categories. So for those that have been around a while, and you probably have had some kind of experience with a relational database type of some kind. So if you look over here on the left, that's where we're going to start working through these. Now, relational databases, a bit of history here is that they, a lot of the theory around all of these different database types actually comes from the 1970s. People aren't as aware of that as they should be, I think. And they think that all of these fancy NoSQL databases, they were just created in the last few years, and new tech, it's like new research. It's like no. A lot of this theory comes from the 1970s. They knew how to do these things. The problem was there were limitations. Yep. Now, the limitation at that point in time mainly was storage. Storage was extremely expensive. So database engine that optimized for storage is what became popular, which is relational databases. Because when you use your data and you actually normalize it into different tables where you only have the data per row that you have for the table, that is a very efficient way of storing the data. So that's why relational databases were the main ones used at that point, because the other ones were not financially viable. And then as we went through the 80s and 90s, people kept using relational databases. And then around the 2000 to 2010s, all of a sudden you'll start seeing a lot of these NoSQL databases, and NoSQL stands for not only SQL, start popping up. And the reason is that all of a sudden we were no longer constrained as much by storage. The main bottleneck became compute. And then cloud came along, and then compute also meant like how many nodes do you want to spin up is kind of like the question.
Yeah.
So that is where relational databases come from. So I started developing on relational databases back in the day because that was what I had available along with files. There were no other database types really in use at that point yet. Doc, what's the first database you built on?
Like any young developer who the first programming language in production was PHP, it was of course MySQL.
Lovely.
Actually, back I didn't even know the term SQL. I used MySQL. That's how we pronounce it where I come from. Like when I heard SQL, first of all, I didn't know what a SQL. So MySQL was my first database I ever tried and used. I think it was running locally on XAMPP or WAMP. WAMP, yes, the local window Apache PHP MySQL thing. But yeah, and this is a great point by Kobus. Like there's a reason why relational databases exist before, and this storage. Storage was expensive, and as storage is getting cheaper, we have so many different ways of storing data in a more efficient way, because you can argue today that the most expensive things are compute. So, and we have storage, well, to check around. But yeah.
No, definitely. I mean, times have changed and things have changed. But interestingly enough, relational databases are still the ones that are in use the most. And the reason for this is there are so many packages built on top of them, and also a lot of people have a lot of experience with this. And when you know how to use a specific tool, you'll try and tend to use that tool to solve the problems that you have at hand. Now, the interesting challenge there is,
Yeah, to be honest, like until like 6 or 7 years ago, when I would hear database, it's just relational databases for me. Like I wouldn't even consider like non-relational databases back then. It was like, I know that things existed, but it's like it's caching. It's nothing serious. But that's not the case.
No, definitely. I mean, I think then if you think that is actually a nice segue into the next database type that most people probably have got some experience with, which is key value ones, like for example, in memory, like Redis or Memcached. Because typically when you've got applications, at some point you need to speed things up, and cache is one way of doing that, because you can't keep hitting the database every time. So a lot of people then start using some kind of key value store where they drop a value and they can just retrieve it quickly to do that. Okay, Denny says DynamoDB. Just to clarify, is that Dynamo as in the Amazon internal Dynamo database, or was it actually DynamoDB, which is the successor that's based off the research and experience we learned there? I'd be very curious, because there are actually two different ones, which is quite a fun one. If we have time, we can dig into that as well. So that's the second type, which is...
Let me ask you a fun question. What is the oldest database you've ever seen in production, running, serving content?
Serving content. I want to go with probably Sybase or Flat Files.
Okay. So
trying to think if there was anything other than that. Yeah. Well,
I have a very specific example, because I used to work for the government, and government is very fast when it comes to IT development. We had a thing in my local where I worked. We had a local database of. I don't even know how to say that in English. It's a very specific term for that. And it was a database so old, it could no longer be migrated. It was running Oracle 5 or 4, I think.
Oh, wow.
And we had one on Unix, on like the Unisys systems where it had terminals.
Oh, wow.
It was so old. Everybody tried to, like, the way to migrate it was really, you would have to do it very manually. Like, and it was so old that we had one guy, one person in the entire city who knew that database, and he would come once a month to back it up. Now,
Jeepers.
I use the term backup super loose, because the backup of that database consisted of printing the database.
Jeepers.
Get a box of papers, like, the box of the ribbon papers, and just use a very old ribbon printer and let it print for 24 hours.
So I would not actually mind getting one of those old printers again, because I actually, that sound, along with the sound of a SIFI drive reading, along with a modem initializing and then making a call, those are like childhood memories. Yeah.
So yeah, I'm sorry, but that was a digression. Even today, some people still use very old databases, and I'm not saying they're bad. I'm just saying it's been a while. But continue.
Cool. So just quickly for those people that have joined us, I see there's a bit of a spike now in terms of the people on the channel. This is today's session for Developers Let's Code. And what we are focusing on is specific ways of helping developers get started with using AWS that are new to AWS and new to the cloud in general. So today's topic is a focus on databases, specifically relational databases. And also we are doing another session next week at the same time on NoSQL options. So not only SQL databases, we'll take a look at all these other fancy ones. I say fancy because I grew up with the relational ones, as we just mentioned, and they to me are still like, ooh, when will I be able to use that? But we're currently working through the different types. So we've covered relational databases, and we just touched on key value ones that we tend to use for caches to store data and retrieve it really quickly where speed is of essence. The next type we have is the document type. And if you've worked with document types, this is probably something that you're a bit more familiar with. Something like, let's say, well, we've got document DB on AWS, MongoDB. Trying to think now of other document database types, but there are a couple of them. But this is basically where you build up the actual document like in a JSON format usually, and that represents all of the data. And now the big difference, as soon as you go away from relational to some of the other NoSQL type databases, is that you tend to duplicate data. And this is the first thing that people struggle with. And this is completely fine. Remember, you're not optimizing for space. You're optimizing for speed and access patterns and some other things. So do not worry about duplicating data. So you'll have a user with, for example, as a single JSON object with all the details, then let's say a list of past and current addresses, the current address, any other details in this massive JSON document, and these document or databases are actually optimized to do these. You've got things called collections in them where you actually get a document out of the collection of documents. Joining data is not something you want to do as much because that does slow it down. And I just realized that I mixed up key value and in-memory. Let me just double check my notes here. I did, because key value is DynamoDB and in-memory is Elasticache, although I sometimes view...
Okay.
Yeah. So apologies for that, but I do sometimes think of like Redis and what's it, memcached as key value ones as well. But
do
technically
they're
memcached
or memcached? Because I've heard people say it both. They
memcached.
Memcached.
I have no idea. Let's just not start talking about kubectl or kubectl or
SQL or SQL.
Yeah, no, we can go into the naming wars if we want to. Okay. Yeah. So the in-memory ones are the ones I actually described, which is Redis and memcache, where you've got a value that you want to access really, really quickly. There are also key values in terms of where you access them with the key and you get a value back, but they're distinctly different in the sense that for them to persist the data usually is an additional configuration, or it's not the primary focus. The primary focus there is speed. Right. Then you get onto a graph database. Now, an example of this is Amazon Neptune, or Neo4j. And what these databases do is they are very good at storing data and understanding the relationship between the different data points that you have. So for example, let's say you're building a recommendation agent where you want to say, if person is interested in category A, so let's say sports, and purchase product B, which is, let's say, a sports ball of some kind. And the fact that I say sports ball and not a specific one should tell you where I fall on that spectrum. And then it'll tell you what other people buy based on this. It's really good at those kinds of like inter-object relations and traversing the graph of data that it has to figure out what recommendations to make. And we've got Goran here as well, and he's actually on Periscope. Wow, welcome Goran. He's also one of our frequent viewers.
Goran is our developer advocate, AWS hero for data. So yeah, hi Goran, select hi from Goran.
So that's a graph database. Then you get search databases. So a good example of this is Elasticsearch. That is used, for example, full text searching. So you've put things like your logs in there, and there are ways to structure that as well as they go in to do indexing on specific things. But it's basically built to be able to index large volumes of full text and then actually search values. That's the most common. You can obviously index other data types as well and make them easier to search. But the primary focus is how do I get the specific info as quickly as possible, and also do fuzzy matching sometimes. So think, let's say you're looking for a specific item and you kind of get the item, or you want to put a wildcard and get me all of the following items, and it actually pulls that back. That's what a search database is. We've got a question here around where can I find the schedule for these webinars? And that should be on the, let me just quickly get the link. I just want to confirm this is the correct one.
If you have it handy, I don't have it with me, but yeah, there is a specific schedule HN-pended that you can see all of the upcoming developer Let's Code sessions. So if you're interested, make
Okay.
sure to
Oh, there we
sign up.
go.
And
I
we
think
also
I
have
have
them.
it.
Do we have them like in dual time zones as well?
Yes, we've got them in
Okay.
two. We've currently got them in the EMEA friendly time zone, which is this slot.
Yeah.
And then what we also have is the APJC, east of the world, Singapore, Australia, India, a friendly time zone for that. And if you want more information, let me just confirm this is, it is the most recent one. I will post it over here. And yes, it actually pasted correctly. Awesome. So there you can actually see the link to the schedule. So what you can do over there is that you can see the upcoming episodes that we have over here. We are in the process of updating. So currently we're in the middle one of the episodes at the bottom. If you look, let me actually just pull it up over here. Do that. Sorry. For those that are interested. So this is what the page looks like. And you can see over here is we're currently on this middle episode. So the next one is already scheduled. And we do have obviously more episodes coming and they are scheduled. We just have to update the website. And that'll probably happen in the next few days for those that are interested in this. But going back to our types of databases that we are dealing with. Then the second last one is the time series database. And happy to say that AWS has just recently GA'd the time stream database type, so you can go play with this finally. And also, it is actually a serverless type database where you only worry about the actual tables that you're using and the consumption of that database rather than spinning up resources and having them running in the background. And we'll touch on that a little bit after this, just quickly once I've completed the list of DB types over here. And these are time series is specifically think like, for example, sensor data, or in my case, I worked in at a startup that did healthcare devices that pulled a lot of different metrics in. They were always time stamped and then did aggregates and averages and math on those, but always time-based math, or usually time-based math. Let me rather say that. So things like what's the average value over this time span, or what's the standard deviation, or those kind of things. And time series databases are optimized to actually firstly store these data types and also then do those operations on the data. So they're a lot quicker for that. And we're talking like millions and millions and even billions of data points. Good example here is if you think Formula One cars, they pull, I believe, 120 or 121 different data points multiple times per second when the race is going. So that ends up being, I can't remember how many billion, but a few billion data points for one race. Which is an insane amount. And yes, you can put that in, for example, a relational database, but it'll be slow. It's not meant for that kind of data in that shape and being accessed with that pattern. So play with time series databases as well. And then the last one, ledgers, are very, very interesting. So what a ledger database is one that it is an immutable database. And what do we mean by this? This is where if I insert a record, I run the command that does create this data set for me inside the database. That is written. And then if I go, let's say, I want to update a value from 1 to 2, let's say. That is not an actual, I go into the physical data on the disk and change that value, and then now it's been updated. No. What we do is you actually write a second entry that says, modify that, and this is the change that I want to apply to the previous one. Because once I've written a record to disk, I cannot change it. And not only do we guarantee that, we also provide you with cryptographic mechanisms to verify the integrity of the data. So if you are in, for example, a highly regulated industry, so let's say, for example, let's say a banking industry, and you want to make sure that every single time a balance is changed and we've got full record of it and there's no way to modify that balance without us being able to see the history of it. This is a good way to do that because you can actually figure out, every single change that was made, and the database itself will then give you, when you say select the value, ultimately you get the current value, but it's based that off all the previous records, and that's how he actually keeps it. So super, super useful if you're in that place. Then quickly, just to clarify, when I spoke about serverless versus normal databases, Darko, do you want to give us a stab at your definition of this? Because it's always interesting finding how people view these.
So when we talk about serverless databases, these serverless databases still run on servers, right? The main differentiation factor here is the serverless part, that it is a different type of operating model. So instead of having a server to manage or a cluster to manage, like you have to in RDS or Aurora or a lot of databases. When we talk about serverless databases, there's nothing to manage. You just focus on the data, you focus on the tables, you focus on what the typical example, the most common example people will point at when we talk about serverless databases is DynamoDB, right? It's our NoSQL serverless database. it runs on something, of course, but you don't have to worry about patching, maintaining, backing it up, any kinds of things. It's called all kind of baked into the operating model.
Yeah, no, that's a very, very good explanation. I mean, basically allows you to focus on what data do I want to store, what kind of queries I want to run, and how do I optimize those. You don't worry about, do I have enough space left? Do I have, is the cluster big enough? Is it costing me money while it's running it? Those kind of things. It's focus on actually building the product instead of, doing admin and keeping the DB up and running. I've spent days and weeks and months on that. So you don't want to go that route.
You don't want to, I mean, mind you, there are still requirements for you to run a non-serverless database sometimes. It's not like, especially because there's no support for all the things in serverless, right? But when we talk about serverless databases, especially when you're running serverless applications, in most use cases, you can go ahead with using like something like DynamoDB, a key value store, or a NoSQL database for your use cases, most of the times, of course. And there are also RDS or relational databases as serverless, such as Aurora serverless, which is still supports most of the things, I guess.
No, definitely. So what we're going to do now is, since we mentioned Aurora and RDS, we're going to dig into the actual meat of today's session, which is the RDS options that are available to you. So just quickly, for those not familiar, RDS stands for Relational Database Service, and it's an Amazon service that allows you, or AWS service that allows you to spin up a relational database and takes care of a lot of the heavy lifting for you. So for example, you don't have to install the actual database engine and set up replication if you want that. That's taken care of for you. Snapshotting the instance, making use of backup services, etc. There are easy ways to plug that in, so you can actually focus on database design, database tables, and actual query optimization, and making sure that your data gets to the database and building an app, rather than spending hours and hours setting up these things and actually managing them. So just quickly, as a subsection of that, what we're going to look at, you can see the database engines that are supported by RDS at this point in time, which is, we're going to start with Postgres, which should be familiar to some people. There's MySQL, there's MariaDB, which is a fork of MySQL. I can't remember how many years back. Then there's Oracle databases and also Microsoft SQL Server databases. Now, for the last two, those you might recognize as commercial databases that have got a license fee associated with them. How RDS works is that that's baked into the per second billing of the database instance. So you don't have to worry about gaining a license, making sure it's on the instance, and making sure it's valid for whatever configuration you want. Don't worry about that. It's all baked into the actual pricing. So it makes it super simple to make these database types or use them as well. Now, the one that I didn't talk about is Amazon Aurora. Now, Amazon Aurora is AWS's cloud scale database that we built, specifically a relational database, to be able to how do you do cloud scale? Because going from traditional multiple machines, because as we know in the cloud, everything fails at some point. How do you build a database that actually makes use of the modern architectures and things in the cloud? So what I'm going to do is I want to quickly take you through the page of Aurora and chat to you a little bit about what it's able to do. So what you can see over here, this is a blog post all the way back from December 2016. So it was with that reInvent Aurora was actually released. So what it does is, and it's super awesome. So quickly set the scene. What Aurora does in a 1 or 2 minute explanation is that it split the concern of the database engine from the storage layer. So typically, if I've got a database and I've got 2 copies of it and I want to be able to replicate that way, what needs to happen is when my database, the primary node, writes to disk, it needs to write and make sure that that write succeeded. Then it probably does a double write as a backup somewhere else to a secondary location locally, like mirroring the drive or something, to make sure that the data is there. Now, that write is actually not just a single write. It's firstly, you write the transaction log, which is that I changed something. Then there's the database engine that takes that entry and then goes and updates the data on disk. That is what your engine actually then reads when it does the queries. And then it also writes some additional information around what happens. Then when replication kicks in, it takes that transaction log, sends that over the wire. And on the other side, your replica will then take that and go through the same steps. So multiple write actions, and it needs to know, how am I writing to disk? How does the log file write? Is it there? How many copies are written? All of that. So the database engine needs to be quite smart. What Aurora differs is that it decouples those. So there's a intelligent storage layer that it uses, which is based on S3. It's actually a entire mesh storage, involves SSDs, and then ultimately also does backup snapshots onto S3. But that when the database engine says, here's data, please go write it, the storage layer immediately writes it to at least 4 locations. In total, it will be at 6, but it won't say, yes, I've written until it's written to in at least 4. And that number is important because it does spread that write over 3 different availability zones. So if I scroll down here, what you can see is that it'll write to 3 different AZs in 4 different locations at least. Right. Which means that I know my data is redundant and safe, which means my engine could just continue. Now, often people go, well, that's probably going to be really slow because you're writing 4 copies of it. But just remember, availability zones have got a guarantee of under 3 millisecond latency between them. That's the upper end. They're sometimes faster than that. And also, we build a special mesh network between the different availability zones to also help handle and speed this up. And then fast disk that actually help with this. So that writes actually a lot faster. And just out of the box, if you switch from MySQL to Aurora, the MySQL compatible version, because it's wire compatible with the database driver, you get about a 5-time increase in performance. And with Postgres, it's 3 times, or the other way around. Remember, it's 3 and 5. I might just confuse the two right now.
The important thing here is that the compute and the storage are separated, right, from themselves. So when we talk about the performance, your compute, doesn't really, the amount of replicas you do doesn't really affect your compute performance. So your database can still go chugging along while its stuff is being written down. So,
and that's actually a very, very nice point that Dark is touching on there is how does this now affect the way replication works? Well, guess what? Your instances don't need to do that writing to disk because they access the same data underneath. In this case, this is just a quick illustration of failure mode. If one entire AZ goes away, you still have access to the data. And if you had an instance in that, you'll just fail over to one and we'll actually show you how to do that. Yeah. And there's a whole bunch of details around the actual failure modes and things available here. But this means that because that storage layer is actually shared between the different instances, you don't have to send the data over the wire the whole time. And that's one of the ways that we actually speed it up quite a lot. Right. Then one more database type in the relationals, well, mostly relational, that I want to bring up is Redshift, which is, when you look at it, you might think it's just a fancy version of Postgres. But under the hood, Redshift is actually a completely different engine that focuses on accessing the data by column and not by table and by row. And the reason this is important is that when you start running massive queries on your data warehouse data, those can get slow. So Redshift is optimized to be able to run these very large queries where it does column-based operations on the data, which tends to be what you do if you're using a SQL dialect to access your data. And we are going to get around to that at the end and show you how you can actually load a whole lot of data into it and then actually use it. But it's very similar, but just be aware that it's a data warehouse. It's not just a normal relational database. And you'll also see that with when you start looking at the pricing, you go like, holy crap, this is expensive. But then you need to take a step back and realize like, this is where you start dealing with terabytes and petabytes worth of data. This is not for your 10 gigabyte type database. Rather use Aurora or MySQL or Postgres and RDS for that.
Yeah, I mean, don't use a Redshift as your relational database just as is. No, you can, but you shouldn't.
Yeah, no, definitely. It's going to be expensive. Like with a lot of things, there are many ways you can do things. There are optimal ways of doing things. Just putting it out there. So then the last one I want to cover is Athena and S3 Select, even though they technically are not databases. And the reason I want to touch on them is that you do use relational database syntax, so SQL. So SQL-like queries. And what Amazon Athena is once again, a serverless product where what you can do is you can run queries across data files sitting in S3. So let's say I create a bucket and I upload a bunch of CSV files, JSON files. You can do Parquet files. And we recently introduced, there was another format that you can do that was recently introduced. It's Apache Spark.
Not Spark, it's R.
RVO, I think it's
something
RVO.
R, something R. We talked about it this Monday.
Yes.
It has a very interesting name. Apache something R. I'll mention it. Give me a second.
Cool. Yeah. But basically, what that does is that you can then run SQL queries against those files. So think about this: upload S3 Avro. Okay. Upload a file to S3 and run a query against it. That is super useful because there's no database to maintain. There's nothing. Literally, the pricing works on how much data you actually load into memory from S3 every single time.
Yeah.
Just quickly, indexing. There's a question from Lost Algorithm. Is that indexing and caching behind the scenes? or more of a once-off convenience. I'm assuming this is now with regard to Amazon Athena. So how it works actually behind the scenes is that every time you run a query, it actually loads the data set into memory, runs a query against it, and then unloads it afterwards. And it's obviously, because this is a big data tool, optimized to run at very large scale with lots of data. It might sound like that's very inefficient to do, but it's actually very, very efficient, and it's very cheap when you start looking at the costs associated with doing those kind of queries. Right. So there's this interesting one when we get to data warehouses where initially, when you've got a certain amount of data, it's cheaper to run with Amazon Athena queries directly on those files. Then you get to a central point where, because you're doing so many queries against the files, and you can actually want to spin up your own Redshift cluster and then run against that cluster because you're hitting the data so frequently. And then on the top end of the spectrum, there's sometimes scenarios, it's not that Redshift is not the cheapest option there, but there are interesting scenarios where if you're not doing frequent queries on a massive data set, it actually becomes cheaper again to use Amazon Athena to do the queries against S3. Even though those queries per once-off is expensive, running a cluster of that size in Redshift would be more expensive. Yeah.
And I think Athena is a very useful thing. Like, for example, I've used Athena numerous times when I would query something like logs. And I know it's not the primary use case to query logs with Athena, but it's very useful because you just dump some data into S3 and then you use Athena on top of that. For example, if anybody here uses AWS Systems Manager has this thing called inventory, where it gathers all the software inventory, all the configuration items from your EC2 instances that are being managed, and dumps them into S3 buckets. Well, it can dump it into an S3 bucket. Then what you do is you take Athena on top and you can take Athena and generate like quick site dashboards out of that data and make your data much, much more accessible. So, yeah.
Awesome. So now what we can do is we are going to go into the console and start creating some clusters. So all you do to do that is you head over to RDS inside the cluster, inside the console. I did click yes. Sorry. And once it's loaded, you can see there's already one up and running that we'll take a look at in a little bit. But you just go ahead and you hit the Create Database button over here. Okay. Now, the first thing you have to do here is you have to choose whether you want to use the standard create or you want to do the easy create. Now, the easy create uses some predefined values for you and make some decision based on the option that you pick. But what I want to do today is actually want to go through the standard create because I want to dig a little bit into all the options that we have. So now the first question that you have over here is you have to go pick the actual database type. And actually, sorry, let me just refresh this page. This is sometimes happen when it checks what's available and what you can launch, because there should be a little Oracle one there available as well. I still have to dig into the why. Okay, so interesting. So Oracle is not available here in this region at this point in time. There might be something at the moment that's preventing us from using it. I would have expected to see it, but we could dig into that a little bit afterwards. So now you have to pick between Amazon Aurora, MySQL, MariaDB, and the flavor that you want. So we are going to go with MySQL because we're going to come back to Amazon Aurora in a little bit. Now, the first thing over here is you can pick the edition. Now, if I did, for example, let's say I pick something like SQL Server. Here, I've got a lot more flavors that I pick from is the enterprise version, standard, web, or express. Postgres has got a couple of different versions that I can pick. But let's just go with normal MySQL. And then we can pick the version over here. You can see this whole list of version depending on what kind of compatibility you have to do. You can obviously go all the way down to 5.5.46. It seems the lowest one. Yeah. But we're just going to stick with the default for the dropdown at the moment, which is 8.0.2. Then what we can see over here is we've got different templates that we can look at. Now, we can pick between production, dev test, and free tier. Now, free tier, if you just start exploring your AWS account, is a good place to start because this will be, when you make choices further down, those will be inside the tier that doesn't cost you any money. So if you just want to play around with that, do that. But for what we want to do is we want to show you how to launch a production-ready database, which is a primary instance with at least one replica in a different availability zone, because then we can show you how you can failover. And that's why I've got that other cluster in the background already running, because this does take about 15, 20 minutes to start up. But we will break things, don't worry. It'll be entertaining. Then you have to start choosing what you want to call this database instance. So let's just call this, let's just make it someone else's problem. So I'm going to call it Darko.
Thank you.
You are now a database. Congratulations, Darko. Then over here, you've got a choice about setting a username. You can either auto-generate, it'll show it to you, or you can go ahead and set one. So let's go ahead and set one. I'm going to set it very securely.
Okay. Password 1, 2, 3. I hope so.
Yeah, very close to that, but just a little bit of variance now. Nobody was able to access this database because we're not going to make it public. And I'll show you if you want to. There are ways, but highly recommend don't do that.
Yeah.
Then you get to the fun part where you have to pick the instance size. Now, given that the type of databases we tend to see in production, they tend to be beefy. So starting off, we have one with 4 vCPUs and 16 gigs of RAM. What we can do is you can see in this list, it can actually go down to quite large. And a fun one over here, you can see the G suffix there, the M6G, which are the Graviton2 versions of the database engines or instances that we launched that these actually run on. And these are ARM architecture and not x86-64.
Yeah, that's a new feature we have.
Yes. We unfortunately don't want to dig into that too much today, but that is a way if you're doing very large databases to get a lot more performance at a lower cost point out. But you can see these are quite beefy. 64 CPUs, 256 gigs of RAM, and that's 19 gigabits networking throughput. Yeah. So these are the mainstream ones if you've got very large ones. But we also know that customers don't necessarily always need these massive ones. So we can go to the burstable class, which starts off at the T2 micros. And they're one CPU or one virtual CPU and 1 gig of RAM. So you can pick whatever you want. And now just be aware, burstable instance types can run out of CPU credits if you're hitting the database too hard, but they also accumulate them over time when you're quiet. So they are a good balance between not too busy and, but you do need to be able to burst sometimes. What you can see is you can also pick a previous generation should you want to. Now, the next part is what kind of storage do you want and what size storage do you want? So the first option here is to pick between general purpose or provision IOPS. And the difference is that provision IOPS is you specify the baseline performance that you want of these SSDs, but they're also more expensive because we guarantee that. General purpose is cheaper, but the performance is dependent on the amount of storage that you pick. And you can see over here, it warns you that under 100 gigs, they don't tend to perform as well given the characteristics. So there's a trade-off between the two that you can make. So let's just make that 100 for now. Okay. Then what you do is you can see the warning goes away. Then what we can see over here is a little button that says enable auto storage scaling. I would highly recommend that you leave this one ticked on because otherwise you don't want to run out of space. But you can set a threshold so you don't have infinite builds if something runs away, because there have been many stories of runaway Lambda functions that saturate databases.
Yeah.
Cool. Now, the next part here is the fun part where we start talking about multi-availability zone deployment. So what you can see is if I want to do a non-production one, I'd select do not create, and this will be a single instance inside a single availability zone. Or I can say create at least one more read replica so that if something goes wrong, we can fail over to that one. Then connectivity-wise, we can pick where we want to actually launch this, and we can pick the VPC. You can see over here, I've got my default VPC, or I can launch a new VPC. And now under additional connectivity configurations, this is where things get a little bit more interesting. So here I can actually pick what subnet group to actually use inside, and that'll also determine what availability zone I'm going to pick because the subnet exists inside a specific availability zone. And this over here, you'll be happy to know the public access is by default set to no. You can launch an RDS instance in a public subnet and say, open this up to the world, please, and then open up the security group to it. You need to have a very specific reason for this. It is a security risk. You never want to open up your database to the internet.
Yeah, I would agree with that. And like, when you say subnet group, does that mean like it's multiple groups, multiple subnets in that group, or?
Yes. So how this works is that when you create, we specify the subnet. You actually create a subnet group inside RDS that references other subnets that it can use. So you can set up one group to point to multiple different subnets inside the same availability zone, if I remember correctly. There's a limitation on that in terms of, because you can imagine if I specify availability zone A, I need to know which subnet I'm launching in.
Yeah, absolutely.
End of the day. So that's the public access. Then what you can see over here is the VPC security group, and a security group is like your firewall around your database instance in terms of how it actually accesses it. And you can specify multiple security groups with multiple different rules. And you can see by default, we're going to just use the default group, and we are going to specify this database to run on the default port, which is 3306 for MySQL. Now, you can obviously change that to whatever you want. If you've got a specific reason for that, entirely up to you. Then how do we authenticate against this database? We've got two options here, password authentication or password and IAM database authentication, which is an interesting one because you can then actually use IAM roles to have different services authenticate against the database without issuing them with a username and password. We're not going to dig into that today, but it is a nice security feature allowing other services to access the database as well. Or, for example, a user using his IAM credentials or her IAM credentials to access the database. Cool. So lots of configuration options. Trust me, this is a lot less than installing a Microsoft SQL Server from scratch. I used to do that as part of my job. That normally was about an hour long, going through all the clicking because there's so many configuration options. Exactly. This is a subset of how you can configure the database available to you. Now, initial database name. Let's just confuse people, and this one we can make not Darko. So it's the not Darko database inside the Darko database cluster. Cool, got it? Right. Now over here, you can see you've got parameter groups and option groups, and this is how you configure the specific database actually. And what these things do is they allow you to change the values on it. So for example, you can enable bin logging, which is a setting that you need to, if you want to use, for example, DMS, which is data migration service that allows you to do replication from this instance to other different flavors of databases. So you can go from MySQL to Redshift or to Microsoft SQL Server, etc. The whole permutation of things you can do there. But this is how you can actually fine-tune them with specific configs that you need for your one. And now we get onto the important one, backups. Darko, when last did you test your backup?
What?
Exactly.
I have never in my life had a working backup, and when I say working, I've never tested a backup, and I have never had to use a backup per se. So, hence, if you do not test your backup, it doesn't work by default. So.
Yeah, Schrodinger. So if this is normally where the point where I go in an in-person talk and I can look at the audience and make them feel really uncomfortable, which I said, like, if you haven't tested your backup in the last week, if there's nothing that you learn about today's session, just go test your backup. Please make sure you can restore it. Just quickly, the reason for this is if you just look at 2019, there were a lot of massive companies, like really big ones, that had issues and they had to restore. And there were issues like, for example, the files weren't there. The files were empty. The files didn't work.
Exactly. It's the famous Schrodinger's backup, right? It works and doesn't work until it's tested. So make sure to test your backups at least once and every while, right? I mean, you don't have to perform the full-on restore all the time, but ensuring that you're actually backing up things and not just trusting yourself is very good.
And what you can see over here is the config for the retention. You can see it goes up, all the way down to 35 days. The default is 7, but you can tweak that the way you want. Then also you can select the window. So at the moment it says no preference, but you can select the specific slot and also the duration you want to spend on this. So you can actually have a timeout should it become too slow for whatever reason. And then you can also enable enhanced monitoring, and this just allows you to get more granularity out of the metrics of your database cluster and how it's running. Then also on the log exports, you can just choose here what logs you want to export, and you can come and edit these values afterwards as well. So by default, it's just the normal application logs, but you can do the additional ones if you want to send them there. And you can see over there, ensure that these are enabled by default. We don't want to enforce it on you, but you can go. So we'll just go ahead and say, boom, click all of them because we're going to be responsible, right?
Yep, exactly.
And here's a fun one. And this is where you start getting the benefit of using Amazon RDS instead of running your own one, is you can enable auto minor version upgrades. So when you think about this version is 8.0.20, if I remember correctly, and I saw that 8.0.21 is out already. So I can say every time there's a new version, minor version that gets released, just automatically upgrade it. And then the next question is, okay, but when do I upgrade it? Well, in the maintenance window. Yeah. So you can actually set the maintenance window. And you can see there's a nice warning over here. You don't want these two to overlap because you don't want to be applying a change to your database as you're backing it up, because then it kind of like, what's the point of the backup? So because we had our, let's just look over here, our maintenance window at midnight, select window. What we want to do is, and we've got half an hour, we want to say, let's do it at not midnight. Let's give it a bit more time. Let's say 2 hours past midnight. And also I give it half an hour to actually do that maintenance. You can make it, I mean, you can.
And does this actually take the database offline during that part? I don't think so, right?
No.
Because of the
no. It depends.
Okay. But is it because, I mean, if you have a cluster set up, I mean, you should not be offline, right?
No, there will be, because what it does in a cluster scenario is that it actually fails over to the secondary, then upgrades the primary, then fails back to the primary, and then upgrades the secondary. Yeah. But if you've got a single instance, then yes, you have got downtime because there's nowhere to fail over to. Because during that period of time, you can't access the database. So yes, but it's worth knowing. And now what you can see down here is that this is the estimated database cost per month. So you can see over here that the DB instance itself is only $13, but because of that 100 gigabyte disk that I picked, that's actually $25. And then also is doubling up the cost because I've got multi-availability zones. So I've got a second copy, the exact copy running, and that's where you get this. And once you've selected all of these...
This is also very important when we talk about the cost, is that the storage amount is just choose what you need, right? Don't over provision. There's no need like to future proof it because it will grow automatically. So if you need a database that needs only 20 gigabytes of storage, just use 20 gigabytes. So,
and watch the space, because we will talk about storage when we start touching about on Amazon Aurora. And then you would go ahead and say create the database, and it'll start creating the database. So let's just click that, and I'll just tear it down a little bit later. And what you can see over here is that now we've got that database that's busy spinning up, this darker one over here. Now what you can see is that I actually created, yes, so the database is priced by the instance tier. So let me quickly just answer that question. Let's just select MySQL again. We'll leave everything on defaults, auto-generate the password. So let's say I pick these very large instances. If I scroll all the way to the bottom now, what I'll see is you can see this is slightly more chunky, but remember this is a 4 CPU or 8 CPU and 16 gigs RAM instances. It's much more, you can see the storage is the same, but the actual compute is a lot more expensive given the size of the instance we're dealing with. Yeah, so you can definitely, that's how it is. So you can see what it's going to cost when you get to the bottom of it. But now what I want to show you is that I've got a cluster up and running over here. It is one of those M5X extra largest clusters, so it's a nice big one. You can see it doesn't have any activity at the moment because nothing's really going on. Yeah. So now when you want to access your database, what you'll see over here is that this is the endpoint, and you get a DNS record. And if I copy this DNS record and I hop over to, here we go, my Cloud9 instance, and I say ping this, this should resolve. Let me just quickly double check if this instance is up. There we go. Okay, I was just waking up quickly. So you can see that this resolves to a very specific IP over here, which is the actual IP of the primary database instance in there. And this is the first part where the redundancy and failover comes in. Because let me go and say, okay, this is the cluster. I have got a single, I've got a replica instance actually running up there. I can go do, I believe, over here, actions and modify. Let me just quickly, I need to remember now how to do the failover. I think you right click on it. It's been a while since I've actions. I can't actually do it over here. Yeah, you can do it with Aurora directly. Yeah. It's not an RDS function, so I probably won't be able to show you the failover over here exactly. But what will happen then is, in the event of a failure, well, with the primary node, RDS will pick up that something's broken. It'll actually change the DNS entry to now point to the secondary and promote it to the primary. And that's how you actually don't have to deal with that. And that's one of the ways that it makes it simpler to deal with this than setting up your own database and worrying about that connectivity. But basically what we have over here is, now that this instance or this cluster is up and running, you can see all the values of how I configured it, the security group rules that I have around it, the replication that's currently set up, etc. Yeah. So this is a normal RDS instance. You can see over here that it's still busy creating that database. Now, what I want to show you is how to create an Aurora database. So let's go ahead back and create the database.
Yeah, and mind you, the creation of databases is one of the longest things you can have on AWS. Like I think this and EMR clusters and just takes the longest amount of time to do. So it's usually a good couple of minutes for this to finish.
Yeah. And normally I think I timed it, it's about 15 minutes, I think, to spin up a cluster. Yeah. If you're doing a single instance, it's about 5 minutes. So in the greater scheme of things, yes, it's slow, but relative to doing it yourself, trust me, this is faster.
Absolutely.
Yeah. I've done this many times. Yeah. So now the difference, we've already touched on how Aurora's storage space is different. Storage engine is different. What we haven't touched on is how Aurora's storage space works. And here's some great news. It allocates space in 10 gigabyte chunks. And also, like with the other RDS services, it actually automatically grows, but you don't have to take any action. So that's super, super awesome. So we're going to pick Amazon Aurora. Now, the first one is first choice here is to pick between MySQL or Postgres compatibility. So you use the same database connection drivers that you would with MySQL or Postgres, and you can pick one of the two flavors. We're going to stick with MySQL. And now what you can see over here is the capacity type has got an option, which wasn't there before, which is provisioned or serverless. Now, serverless in this case doesn't mean that it's a database where you only pay for the time you access and make queries against it, unfortunately, but you can scale down to 0. which is useful. So what serverless does is that you create a cluster that the compute portion of it, because we've decoupled compute and storage, we can actually add and increase the size of that compute portion and the number of them running on the fly as your requests come in. So you can select this and then say scale between these following two points based on the values that we have. So from that perspective, it's super useful if you've got fluctuating loads over time. But if you want provisioned upfront where you know exactly how much capacity it has, you can pick provision capacity. So let's just go with serverless. I can show you some more of the options because it does differ a little bit. Now, this does limit you to in terms of specific versions, in terms of compatibility. And you can see details here on the side. And there are quite a few ways that you can set up Amazon Aurora. You can have it span multiple regions as well, with read replicas, etc. But for today, we're just going to go ahead and select the default. So let's go ahead here and say 2.07. Sorry, not the default, the newer one, 2.07.1, which is MySQL 5.7 compatible. Then settings, like before, this one, let's just do it this way around again. Starco. Cool. Credentials, once again, let's just set that nice fancy password. Cool. And now this is where the fun comes in, the capacity settings. Now, what's the max minimum? Now you can see over here, the minimum is 1, and you can go maximum, you can go all the way up to 256 virtual CPUs as well as 488 gigabytes of RAM. And you can choose what you want here. So let's just set it to 4 for now. And over here, we can say additional auto-scaling configurations. So what you can see over here is that you can force the scaling capacity to the specific values when the timeout is reached, and there's some information on how you can do that. And the important one that I want to highlight is this pause compute after a specific amount of inactivity. So what you can set over here is, let's say in the evenings, you can say if for 2 hours our database has not had any hits, we set it to 0, then it'll actually scale down to 0, which means you won't pay for the database while it's running at that point. You'll pay for the storage that you have underneath, but not for the actual compute engines to run. So this is useful for, let's say, your dev environments, testing environments, or if you've got a system that doesn't run 24/7. So very, very useful for that. And then connectivity, similar to the previous one, we pick which VPC it runs in. There's some additional configuration in terms of the subnet groups, the actual security groups you want to do. And also, this is an interesting one that's new, is that the Web Service Data API. Now, what is this? Darko.
Well, I mean, my understanding on this one is that you can actually have SQL Web API endpoints. So you can make queries from within, well, just the RDS console. You don't have to use the MySQL client to make some queries. I'm not sure how production grade this is. I've never used it in production grade, but it basically gives you the ability to, instead of running SQL queries through port 3308, you can run it through HTTPS. So
yeah.
HTTP.
So yeah, no, that's a nice summary. So basically, this adds a proxy layer or data API layer on top of your instance and allows you to make those calls with HTTP. Now, where this becomes important is, if, for example, if you are using things like, let's say, Lambda functions, because Lambda functions, you could, for example, include the entire database driver and make wire-level TCP connections to the database. But a couple of issues with that is that, one, you have to include the driver, so it makes the Lambda function bigger. 2 is that you don't know how many of those Lambda functions execute in parallel, and then managing the connection pool settings is a lot harder because they each need to be aware of each other and how many are running in parallel. But this data service API will then, or the RDS proxy will actually help you with that and actually take care of that for you to make it simpler. You manage your connection pool in one place. Then we've got a couple of initial or additional options over here. So let's just to keep the confusion going. This database is going to be called Darko on the not Darko database cluster. And over here, you can see once again, parameter group is just those values that you can set, and you've got different settings. You can create your own ones with specifically tweaked values as well. Similar backups over here. Now, this backup defaults to 1. And part of this is that you can go back to certain points in time snapshots with Aurora because of the way this storage engine works, which is super useful. And you can backtrack, I think, into granularity of like a minute or 5 minutes into the past as well for it. Yeah. Once again, copy snapshots. You can enable encryption for the actual data. You can see that's on by default. And also enable deletion protection means you can't just delete the cluster.
When it comes to like backups, what is the resolution of backups in this case for Aurora? Is it like every minute, every hour, or?
I'd have to double check. So this is a full backup once a day, but the actual, because the storage layer, that I believe is in granularity of, I think 5 minutes or 1 minute.
Yeah. There's like a way to roll back. I know that like DynamoDB has like a rewind function where you can rewind up to like a minute or so.
Backtrack, there we go. Yeah, Backtrack's what it's called, yeah. Let me just quickly get the new Backtrack. You need to enable it for certain clusters. There's a cost associated, and let's just quickly see. You can backtrack. It seems to be individual minutes.
Well, there we go. Yeah.
Yeah.
So that's amazing.
Yeah. So that's useful if you run into that scenario. We've really broken the production database, and you need to quickly backtrack. Dish. Cool. So now what do you have to do? And I do realize, Doc, I know you unfortunately need to leave us soon. He's got another session.
Yeah.
You just go ahead and you can create a.
I have something in 5 minutes happening. So I just want to say thank you all for joining in, and thank you for the questions we had here. And Kubus, thank you for inviting me to be part of this thing, even though I did nothing. I just commented on it.
It makes it easier for me to talk. Now what I'll have to do is, actually, where did you go? Oh, here he is.
You need to bring back
Mr. Sidekick.
Yeah, Mr. Sidekick.
For those of you that haven't met him, this is my very, very snarky monitor stand. He's got a smirk.
So
yeah.
I'm gonna drop out, but feel free to listen to Koba still. He has a lot of things to explain. So stay online, and I'll be seeing you some other time on the same place.
Probably tomorrow.
Probably tomorrow.
Yeah. Cool. Okay. Cheers, Marco. Thank you.
Cheers. Bye.
Cool. Bye. Okay, so we're going to continue a bit more. Just for those on the stream, I've got a couple of things that I want to go through still before the end of the session. We've got until, I believe, past before I need to get off the air and it's someone else's turn. So we're going to continue if you have some more time. Also, now that it's just myself, please chat to me in the chat, send me questions, ask me things. It makes my life a little bit easier than just sitting here and ranting at the empty room in front of me. So that is how you create a serverless Amazon Aurora database instance that is able to scale up and down. Darko's name was in Cyrillic. That is likely him. I think he just made a setup, but Darko is actually from Serbia, which means he actually and he speaks Serbian, so he knows Cyrillic. For me, it's just lots of funny characters. I'm unfortunately just used to normal, I think, the Latin alphabet. So yeah, cool. So now let me quickly check my notes where we are now. We spoke about all of those already. Now what we have to cover is the difference between a snapshot and a backup, because that sometimes confuses people a little bit. So when we set up backups on this instance level, what that actually does is that under the hood, it makes use of effectively EC2 instances running. And then when it does a backup, it actually takes a snapshot of that entire instance, like you do an EBS snapshot inside your normal EC2 instance. So it's the instance size along with the entire disk, boom, drop it. Now what you can do is there's a service, AWS Backup. Let's just quickly get over here. Backup. Oh, sorry, if I can spell backup. That you can use, and you can actually set this up to do database level backups of your data. And this is awesome because this service actually just charges you for the storage of the data. Let's say we can start with a template, we can build a new plan, or we can define the plan using JSON. So let's use a template. I want, let's say, 35 data retention, and the backup plane name is just, let's call it Quibus. Cool. Now I need to do the rules. And over here we can see there's a backup one, and it's going to use the backup, the default backup vault. Cool. Quickly, a question here. Let me just pop that on the screen. Which is, the autoscaling looked really interesting for infrequent workloads. Could you maybe go into how that behaves when spinning up again? Yes. So since there's a compute portion that needs time to come back up again, it does take, the first time you send it a query, it'll take, I might need to lie to you now if I remember offhand, but I've got 60 seconds in my brain for some reason that it takes for the instance to come up, but please verify that. So the first time you query app, what will happen is it'll be down, and then it'll take, I'm fairly certain it's 30 to 60 seconds, because I know we use it for some internal reports, and when it's offline, you just wait 30 seconds later, refresh, and then it's back up. And then what will happen is it'll say, okay, cool, go to the lowest compute quantity that you've got specified in that between the minimum and the maximum. And then as soon as it's up and running, it'll just start accepting connections. So you don't have to actually do anything else. It just comes back automatically based on the settings if you enabled it to scale down to 0. And like I said, especially for apps that are not busy overnight, or what do you call it? Things that switch off at night or need to be switched off automatically. It's a way to not worry about that. Cool. Okay, backup rule. So over here, what you can do is you can create a new backup rule. So we can just call it, let's say it's Quibitz's rule. And you can pick this, the frequency. So I'm going to go for daily. Oh, sorry, I can't use an apostrophe and underscore only. Let me adhere to the rules. And this is now, so the template I used up here created a rule already for us. Where was it? Well, I've now overwritten it because I'm adding a rule. And I can specify what backup window to use. Now, remember when we created our instance, we specified the backup window, but I can actually customize and override that should I want. Once again, please don't set this backup slot to be the time when you're busy applying minor upgrades, because then your database will likely not be in a state that it can be backed up properly, or your backup will just fail halfway through. And then what you can see is over here, start within 8 hours of that. You can obviously decide how to narrow that down because it picks a random slot between that gap. And then what you can say is it needs to complete within a certain amount of time. And this might sound like 7 days sounds like a lot, but just remember, this database could be huge. It could take you literally a day or two to actually back up it. And this is interesting. So if you are using EFS as part of the configuration, you can actually do different storage tiers as well. And over here, you can say we use a specific backup vault, which has got rules, and you can create different ones as well. So let's say quickly create a new one, and you can specify how to encrypt this this vault as well. So you can have different encryption keys for the different backups that you're creating for, let's say, regulatory requirements that you have. We're not going to be doing that today. And then what you can do is you can also say, where am I copying this? And it's optional. So if you do want to do cross-region backups, you can actually say, copy this to a different region. So let's say like Stockholm over there. So there are quite a lot of granular details that you can do over here. So now let's go ahead and say, add this backup rule. Now we can see over here, I've got my 2 backup rules. Then for the actual backup rule, you can actually add some, or sorry, this backup plan, you can add some tags as well if you want to do. And now what you can see over here is that, hey, Darko, he's now lurking in the chat. Thank you. Now what we can see over here is that they're also creating application-aware backups. So there are some third-party software running on EC2 that can be aware of these backups and actually make use of them as you create them. And you can see over here, I can tick this specific one, but do dig into this if this is something that you're interested in. And now I'll go ahead and say, create the plan. And now I've got my backup plan. And now you can see that this is an additional backup of the actual database. Now you can see at the bottom, that part is disabled. And I can see the details about this. I can also see, for example, the different backup vaults over here. And there's a whole bunch of settings in here. I kind of want to go into protected resources because I'm not familiar with it, but we're not focusing on that today. So let's just skip over that. But that's another way how you can set up additional backups for your instance and then actually, like I said, cross-region replicate them. Let me see where I am with my list of things that I want to go over here. Boom, 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 boom. Things with Aurora that I didn't cover is that, firstly, because of the way that it does those writes, which is it sends out the 6 parallel writes across the 3 different availability zones in one go. And as soon as 4 of those 6 have acknowledged that they've written, we acknowledge back up to the database engine that the write has completed. You've got copies across all of the different availability zones, which means that when you do read replicas in different availability zones, they aren't reading from the data source somewhere else. They're actually reading inside that one. Yes, there's a question asking, can you ask about ODS proxy? Yes, I will hopefully be able to answer the question. So please feel free to answer. This whole session is about me telling you about Amazon RDS and relational databases and also helping you with questions along the way. It's not just me broadcasting and making a lot of noise. So please, questions. While we wait for that question, so part of what makes Aurora so much faster is that because of the way that it writes the data means that it's fast, it's actually able to write faster. So it's very good for write-heavy operations as well. And also because we have got copies across, or 6 copies in total, read replicas can actually read better as well. So it's also good for read applications. And when you set up a cluster with Aurora, you actually get a secondary DNS for read-only as well, that it'll figure out in which availability zone you are, is there a read replica in that AZ, and how to actually then access that on the IP level inside that AZ, instead of going cross AZ to actually access the data. So that is all good and covered. Also, be aware that I think we mentioned earlier that Aurora starts off in 10 gigabyte storage sizes, and it can automatically grow in 10 gigabyte increments in terms of reallocating that kind of storage. Now what I want to do is let's just quickly double check over here. If I go back to my clusters, let's just see what we have up and running here. Okay, I was not paying. Okay, what I'm going to do is I'm going to quickly create an Aurora cluster because I just want to show you the failover. Actually, we might be able to, if I go back over here, databases, I just want to see if I do a reboot on this normal MySQL community. Yes, this is the one that's the highly available. So let's go ahead and say reboot this instance quickly. Here we go. Reboot with failover. I need to just quickly double check what this behavior is because I can't offhand remember. Boom, boom, boom. And this, just for those who are interested, this is how we also find out things, is we go over here. Read replicas, you can reboot the source database and it's read independently. After reboot completes, tip, tip, tip. Reboot with failover. Yes, so I want to reboot and do a failover. So let's just say that, say reboot. And now what I can do over here, if I'm quick, if I keep on pinging this, what I'll see is that the IP is still, I think this is still waking up, still the same. And I should be able to see that it changes to the other one if I go over here. Let me just make it a little bit smaller so it fits in here. It's currently rebooting. Let me just refresh that. 30 seconds later, normally, let's go back. Here we go. Let's just see. So the IP is 81. I would expect this IP to change if I was setting the other way around. Just give it another few seconds. While we're waiting, just the Helena, please feel free to ask questions about RDS proxy. I'm more than happy to try and answer them for you. At worst, I'll quickly need to whip up the documentation and we can have a chat about it there. Oh, not reboot with failure, don't paste things. Let's just see, and there we go. Okay, so what we can see over here, this is what I was waiting for, is that because that primary node had gone down, it actually took a few seconds for it to figure out and realize that node is not up anymore and also fail over to the secondary. And now you can see that the IP actually resolves to a different IP. And part of this is that I don't have to change the actual database connection string because the DNS value for it is still the same. Cool. Here we go. Question quickly from Dehana is, what is the benefit of using RDS proxy? Because if I'm not mistaken, it's just about connections to database. Some of the Aurora is this built in the config and set to a pool number and idle connections time to DB. Yes. Okay. So let's dig into this. So the example that I spoke about when you're using Lambda functions also applies to when you're running your application and running multiple copies of it. So here's my application. In there is the config for the database driver as part of either the database driver or the ORM that I'm using. And I tell it, you're allowed to have 40 connections to the database. This is this single instance of my application running. I've got 3, 4, 5, 6, 7 other copies of that running, each with them configured with a database connection pool of 40, which means actually I've got a database connection pool of 200. If I've got 5 of them with 40 each. Now, the challenge is that this is fine in this scenario because let's say your database is able to handle that level of database connections, because running multiple queries in parallel does slow down the database. Extreme example, you just did some kind of promotional event and all of a sudden thousands or hundreds of thousands of people start hitting your website. Now, you've got you did proper design, you've got autoscaling rules in place. So it sees that web traffic is increasing. Let's increase the number of instances up to 50. Now 50 instances with 40 connections open each to the database. Your database will not be having a fun time, which means it'll start falling over. And it's this type of scenario along with the Amazon or the AWS Lambda scenario where what you can do is by using the RDS proxy, it knows the connection to the database in terms of how many connections there are and managing those connections. Each one of these instances will then just connect on HTTPS to that actual proxy and then send the request that way. And then that's how it will actually then send it through, where you don't have to worry about how you want to configure that connection pool on a per instance basis and have them know about each other and reconfigure on the fly and that kind of complexity that you would deal with. So that's one of the ways that it helps you with that kind of scenario. The second scenario is that also the credentials live on the RDS proxy layer, not on the actual instance layer, because the instances will then have an IAM policy that allows them access to that specific RDS proxy. And then based on that, they'll be able to communicate with it or not. The actual proxy layer is the one that has the credentials to get to the actual database as well. So you don't have to farm out credentials to every single copy of the application running, which when you start rotating credentials, that becomes a bit of a pain, because now you've got, let's say, 50 instances, all 50 of them need new credential set. You need to keep track of how do you change them. Do you create a second credential set, then add them to all of them one by one to make sure that they flip their connections, because you don't want to worry about that. Where RDS proxy layer, it takes care of that for you. You can actually integrate with a secret manager to do password rotation for you seamlessly. So you don't have to worry about that at all. It's taken care of for you. Let me quickly have a look over here. Next question is, what's your experience with changing DNS entries on the fly concerning SQL drivers, runtime OS caching the DNS entries, not performing new lookups? Is that the issue? So yes, this does sometimes come up. It's as the old joke goes, it's always DNS when there's a problem. So how it works is that when a computer does a DNS lookup, there's different behavior. It could decide to keep the response that it gets, which is an IP address, in a cache somewhere, and applications could do that, database drivers can do that, all that. What I would expect with most of these database drivers in terms of their behavior is that when I've got a connection pool of, let's say, 40 connections, and I'm busy running them, they're in flight, and now they start timing out. When I create a new connection to use, because that's what the effect that'll happen is that because that socket to that specific IP is no longer available, that will time out, and the driver will need to say, I need to initiate a new connection that I'm going to have inside my pool of connections that I can farm out to different queries, and I need to establish a new socket connection. Therefore, I need to go look at the config and say, what's my database server that I'm hitting? Oh, it's a DNS record. Oh, let me go do a lookup. But obviously, there are things on the operating system level you can do to tweak that up. But usually that shouldn't be a problem. Obviously, with a massive asterisk that says it depends on configuration. But by default, it should just do those connections should time out. It should redo the DNS lookup, and then it should be able to get to your new database instance as soon as it's up and running. Cool. Please let me know if you've got more questions. So that was the failover that I showed you over there. And I'm not going to show you, loading data into the database. We can do that where you use the MySQL client to actually load it and run queries against this database. But from your perspective, once you've launched your RDS instance or cluster or Aurora serverless database configuration, you don't have to worry about maintaining the database, and you just worry about what's the username, what's the password, and the actual database that I'm dealing with, as well as the DNS entry for the server. And as you can see, we've now been going for 1 hour and 12 minutes explaining a lot of things, but in theory, if I go back here, let's just check. That other cluster is already up, and let's just confirm. This one is still rebooting. Yeah, but that other multi-AZ with replication setup one is already running, and we only touched on that, I think, at about half past. So if you want to time this, like I said, I think it takes about 15 minutes to spin up that cluster. So that's a lot faster and allows you to focus on actually building the app instead of that. Let me just quickly scan over here. Please do keep the questions coming. I really like the interactive nature of these sessions rather than me just talking about all the things that I have to worry about and talk about over here. Now, we did touch on that maintenance window. Now, if you've got a cluster with a primary and a secondary or multiple replicas, and you've got a maintenance window to do the auto minor upgrades, what will happen there is that it'll use the failover mechanism as the way to actually then go from the one instance to the next one when it does the upgrades. Because what you don't want is that I've got a cluster with, let's say, 2 or more instances. Let's shut them all down, upgrade them all, bring them all up. And, firstly, we hope the upgrade worked without breaking. And secondly, nobody worried that our service was down for a while, because guess what? It takes time to reboot an instance and apply a patch to it. And so what it actually does is it upgrades the instances, does a failover, failover, upgrade, failover, upgrade through the list of instances you have available. So that's how it'll actually do all of those minor version upgrades for you. Let's have a look over here quickly. What else do I want to cover today? I can dig into a little bit with Redshift as well if we don't have any questions coming for those that are interested in data warehouses. So as I said earlier, Redshift is I think long ago started. Hey Ganesh, welcome. Ganesh is also one of our regular viewers on many of our shows. So quickly, in terms of downtime, yes and no. There's the usual failover downtime that takes a few seconds to kick in for this when you do these maintenance windows to upgrade your database. And that is the only downtime you have to deal with. So other than that, You don't have to worry about scheduling 5 minutes or an hour of downtime to actually deal with that. Let's have a look over here. Next question is quickly from Lost Algorithm. You mentioned an SQL dialect compatibility of Aurora earlier. Is that complete compatibility for all features of the specified version, or are there Aurora specific things to consider? Yes, there are specific considerations. If memory serves me correctly, Postgres, Aurora. Actually, let me just quickly Google this. I just want to make sure. Sorry, there's a reason why I'm doing it off screen now. Aurora, Postgres. Just double check. Yeah. I can't confirm, but I see there is public mention about it, so I can actually bring it up. Let's put it on the screen. Sorry for the silence over there. I just want to double check, because what I want to talk about is stored procedures, because I know that's one. Stored procedures. I mean, we can see over here that there are Lambda functions being able to call stored procedures. Go away. Sorry. And what we can see over here is that compatibility is fully compatible with the open source version of PostgreSQL. On the stored procedure side, we are planning to support pull, PGSQL, TCL, and JavaScript via engine. We are planning to support all of the Postgres features and extensions that are supported in Amazon RDS for Postgres. So yes, there are plans. So it's fairly compatible, but I would go look, because there are definitely some caveats in terms of what it supports. So always go look at it. Yeah. So, no, definitely ask me directly. I do not mind ironing them, and you can see me how I Google. Yeah. So, any more questions coming? Please send them my way. And what I want to do now is I want to jump into the Redshift portion of the console over here. Like I mentioned earlier, if you want to spin up a Redshift cluster, you can see already I've got one running, because that also does take a bit of time to spin up. You can say create cluster, and you go through a whole bunch of options over here. Is this a production one, or do you want to use the free trial? So a free trial here, because it differs between the different services, is you can spin up a cluster for, I think, a month. The reason for this that we limited is that these clusters are quite expensive. You can see the pricing over there. Let's just take the question away. Thank you, Lost Algorithm. Is that these are the configuration options, because if you take the normal production version and I choose between, for example, the storage dense, or do I want high performance if I want to be running queries at scale? And now, once again, just understand that if I go for the big one over here, we can see that I'm spinning up a cluster with, let's just see how big we can take it. 128 instances, each with 48 virtual CPUs, and also up to 64 terabytes of storage per node. Now, as you can imagine, those are very, very, very beefy instances. So obviously that'll be $1 million per month. That is very expensive, but you get an insane amount of compute power with this. So if we go for the other high performance one over here, and we say we just want to spin up 2 instances, that is $5,000 a month. But like I said, these are very, very big ones, and this is for a warehouse, and you typically won't do this unless you've got a few, I would probably say not terabytes, petabytes worth of data, because you can go, you can do, let's think quickly, terabytes or petabytes? Definitely terabytes as well, because you might be doing these queries very frequently on the data. So not just the size dimension that you have to take into account, you also have to take the frequency of queries. Because like I mentioned earlier, if you have got data of a significant size that you aren't querying frequently, have a look at Amazon Athena and solve the data in S3 and do the queries against that, because that'll possibly work out cheaper than this. But how you create the cluster is similar to this, where you pick the instance sizes you want. You can select the number of nodes that you want on it, and then it gives you a configuration summary. And then also, for example, what you want to call the database, the port number to use, password for the database. And over here, you can see cluster permission. So I can actually attach IAM roles to it to be able to call out into other services in AWS and interact with it as the cluster itself. So for example, accessing a S3 bucket, there are a couple of ways that we can set this up to give it permission to do things. Additional configuration over here, let us disable defaults and see what we can configure over here. So let's take a look at network and security. Similar to the RDS instance, we can go ahead and set up, pick the VPC. Then we can pick the security group to put around this cluster. We can select the actual subnet group to use. And then also what we have over here is enhanced VPC routing. This is, if I spin up a Redshift cluster, I can force all the traffic to always be inside the actual VPC instead of being able to go out of the VPC, I believe. And over here, what I can do is similar to an RDS instance. You can actually pick whether or not to make this cluster available publicly or not. And once again, just please, making it available publicly is a security risk. You don't want to open up your database to the world and accidentally have people access it. Sorry, I didn't know that I had what left. Next, database configuration options. Let's have a look over here. Similar to the normal database instances that we're dealing with, you can specify different parameter groups to configure it differently. And you can also, for example, encrypt the actual data on the database. Now, there's a new option here. It's not just AWS KMS, which is Key Management Service, but you can also use a HSM, which is a hardware security module. And I actually have some experience with these. They're quite, I never actually saw one. I've seen pictures of one, but they are physical devices where you load. So when you think about encryption, it's not just like, here's a passphrase or here's a key and actually encrypt it. It's a lot more complex than that. You've got, they normally refer to your PKI, which is public key infrastructure. So when I have an encryption key, I can create a key, which is called the, I think I still believe that's called the master key. And then you can create derived keys from it, saying these are, let's say, 50 different keys. And if I encrypt the data with any one of these 50 different keys, the master key can actually decrypt it, and also some of these other keys can decrypt it depending on how you set this up. And what an HSM is a mechanism for actually, it's a physical device that actually handles these keys for you and the generation of these keys and the life cycle of these keys as well, and make sure that they all work together. So you can actually use your own hardware module to encrypt your data in the cloud, because that is sometimes a regulatory requirement with some of the customers that we work with. Or you can use AWS Key Management Service, which allows you to either use keys we generate inside the account for you, or you can actually bring your own keys to then encrypt your data for it as well. Then under maintenance, similar to the instance as well, we've got some maintenance windows where we can go and change or decide when we want to apply changes or do specific features. And over here, you can see the different versions over here. So we can say we want to always be on the current approved version of the cluster, or we can say trailing, which means that we are one version behind. So this depends on your appetite for risk when new things roll out. So when we do roll a new version of Redshift, obviously we do a lot of testing to make sure that it works. But there is a chance that we miss something, like with any software you release. So if it's mission critical and you simply cannot live without it, I would go for trailing, which is one version behind, because then what happens is by the time we go current version +2, the bugs for the current version +1 should have been resolved already. So take that. And also, if you do want to go, you can go with preview if you want the latest features as well, and actually look at the beta features. But for those not familiar, when we are talking about cutting edge and bleeding edge, we refer to cutting your fingers. And if you go past just slight cuts, it means you're doing deep cuts and your fingers start bleeding. And that's where the term bleeding edge is actually from. So just be careful if you want these. And I wouldn't select preview options for production clusters. Just you can see over here, preview for CrossDB is a feature that you can play around with. Please don't do this production. So select either current or training for it. Then monitoring over here, we will have a bunch of monitors that we can set up. We can set up additional alarms, and we can set these alarms based on, let's say, disk usage. And we can actually decide how we want to handle that. Because remember, these have got fixed storage per instance. So I can, for example, have this posted an SNS topic. That SNS topic can be listened to by a Lambda function, and that Lambda function can execute a command that says, okay, you're running out of disk space, add another node to the cluster, and then it rebalances to do that. Or there are a couple of ways you can actually deal with running out of disk space as well. And then lastly, backup, everyone's favorite topic. You can see over here, we've got the backup configured to be a single day retention, and we can do it either 1 day or 7 days, or indefinitely keep every single copy. Now, the reason these are less configurable than before, just remember, we're dealing with a warehouse. A warehouse has got a lot of data, usually, like large ones. So you want to think a little bit more carefully about how you approach your backups. And also remember, a warehouse itself is something that you can rebuild out of the existing data sources, because you are pulling data from all over the show, multiple different databases, different database types, different database families, so SQL and NoSQL type database families. and bringing them in, manipulating the data into different shapes and putting it in this warehouse and then running queries against it. So let's say you lose this warehouse. That might be bad for business in terms of it can't execute certain queries, but you can spin up a new instance and theoretically you can just pull back all the data, and obviously it'll take time and it'll overload the database for a period, so you won't be able to run queries as quickly on it, but you can actually build the data up again from all of these different sources. So this is why you've got a few less options here with a backup available as well. And then you would just go ahead and say, create the cluster. Now, I'm not going to create a second cluster because they are quite big. And I'm going to go all the way up here and say, let's go look at our cluster that I have. I have got a cluster over here. And we can see this is a new DC2 large, so dense compute. And I can, for example, run queries. So let me quickly show you how that works. So these are the queries that have run in the last hour. So I can actually take a look, but I can change the granularity to look at whatever value makes sense to me. And now what I can do is I can actually go run and query the database directly. So what I'm going to say is let's create a new connection. Oops, sorry about banging that. And I can select the database. I believe I called it dev. The database user is AWS user, third time lucky, and punch in the password. And to the database. Let's see if I got the values. I can't remember if the database name was dev. I think it's dev. But we should know in a few seconds. Yep, I got it right first time. And now what I can see over here is that because this is a brand new Redshift cluster, it's empty, I can actually see all the different schemas. So the schemas are the different databases inside it. And I can should be able to, for example, say create database. Let's create database. I'm now having a brain fart. Apologies for that. Let's just say Quibus. Run. I can't remember if it's this or if it's just create Quibus. Let's just see if it completes. Now, obviously, you might be wondering why is this slow. Remember, this is a query that goes over to the actual. So this is an interface to a system that then sends the query to the actual system. But what I can see over here is if I refresh this, because the query did succeed. Oh, sorry, I didn't create a new schema. There's just now a new database over there. So what I can do is I can change my connection, and I can say new connection, database name Quibus, database user AWS user, database password, and connect. And let's just see, I should be able to, yep, there we go. And I can see over here, I'm now connected to the new database. And now this is where, if you want to run queries, normally for a warehouse, you've got other tools that you put on top of your actual warehouse to actually do visualization or build up cubes from the data in memory to be able to slice and dice and do things like that. But if you've built warehouses before, you might be familiar with these. But this is where you really start doing deep analysis into the data. And this is where Redshift is really good because it, like I said, underlying the engine actually uses columns and optimizes for accessing data via columns instead of rows and tables. And you can also, for example, if you use the Parquet format, importing data into Redshift is incredibly quick. You can import many millions of rows in a few seconds if you need to. I'm keeping an eye on the time, and I do see that we are now at 27 minutes past the hour, and I've only got another, 2 minutes left. I think something's running slow somewhere. There we go. 2 minutes left. So what I'm going to do is I'm going to ask if anybody's got any more questions or if you've got any suggestions of content that you want to cover in future. And while those questions are coming in, just quickly want to do a shout out to, if you did enjoy this session, it will be on my YouTube channel. I will quickly put the link up here. Let me just quickly make sure that it's working. This cloud. It should just be youtube.com Quibus cloud. And yep, that is working. You can go over there. And also, we've got multiple streams per week. If you want to join us for questions, this isn't the only one. This is one of, I think, 5 that I'm doing this week alone. So on Wednesdays at 11 Central European time, so whatever you are in at the moment, minus 3.5 hours, is when that session starts every Wednesday. It's a rotation between the different people on the developer relations team that we go ahead and answer questions. And then also we have got the AWS Africa office hours tomorrow at noon, so at 12 South African Standard Time. And yes, I do know that tomorrow and next week one will differ because of the DST changeover. So from next week, it'll be the same time as the EMEA AMA session on Wednesdays, but this week it's 1 hour later. Then Darko and myself do streams every Friday between 11 and 11:30 Central European time. And some of the other developer advocates, for example, there's the Nordics office hours. There is the DACH office hours for the Germany, Austria, and Switzerland. We've got the Benelux ones as well. If you are interested in finding out the schedule, just have a look as well at twitch.com/AWS/schedule. So I'll put this here in the chat for you as well. I see there's a question that I'll quickly take as well. So you can see over here, you can see the schedule over here. Let me just quickly pop mute. There we go. Otherwise, I confuse myself. So you can see over here, this is the session that we are in at the moment. There's a lot of different things happening the whole time. The question that I had up here, which was how different is using CloudFormation method to build Aurora. I'm assuming this is referring to infrastructure as code and using CloudFormation to actually build out the cluster. The difference is that you are defining it as code, and I would highly recommend everybody do that when you're building any kind of system out that you're going to use long term. If you're just playing around, I would recommend clicking in the console as well, just get a feel for how to do it, spin it up quickly, use it. But then as soon as you get even slightly serious, start using some kind of infrastructure as code tool. So CloudFormation, AWS CDK, Terraform, Pulumi, there's a whole host of those. And if you are interested in infrastructure as code, definitely come join Darko and myself. It pretty much comes up almost every single session that we do because we use it the whole time and we love it that much. I hope that answered your question, because I do see we are on the half hour now and we have run out of time, unfortunately. Actually, a minute over. Oops. Luckily, there's no show, so I'm not in trouble yet. But I do have to say thank you for joining today, and hope you found this useful. Yes, last question. The question around the Africa office hours, yes, they are on my YouTube channel as well. You can also look if you want some other content that Darko and I did before. Let me just quickly pop that out here. YouTube.com. Oops, sorry. If I can type it /not not Darko. There's a whole long running joke on that. And please join us or have a look at the content over there. And also, did I type it correctly? Yes, I did. Give us a subscribe, because then you can see when we release new content. Currently, things are a little bit quiet because it's reInvent season. And we are working on a whole bunch of very, very interesting things behind the scenes. I would love to be able to talk about them, but sorry, I unfortunately cannot. But yes, keep an eye on that. And yeah, keep an eye on YouTube channels and Twitter. Come follow us if you find these things interesting. And hope I helped you, and hope to see you next week again when we talk about NoSQL databases and all the different types that are available on AWS and how to use them. And with that, adios. Thank you.